System of linear inequalities. These work just as the same as system of equations. The only difference is they use greater than, less than, greater than or equal to, or less than or equal to symbols instead of the equal signs. To graph these, you follow by these three rules. Graph using their slope and the y-intercept. Determine the type of boundary line. That depends on the symbol, inequality symbol. Greater than and less than get dotted lines. Greater than or less than or equal to's get solid lines. So don't connect your points until you look and see which sign you have. Lastly, determine your solution region. This is where you have to shade. This is one big difference between systems of equations and systems of linear inequalities. To determine where to shade, again, look at your symbol. Greater than and equal to shade above the line, because if anything is more, it should be above, right? And less than or equal to shade below the line, because if it's less is not more. That doesn't work in math. Okay? So you shade underneath the line. Here's a system of linear inequalities. I wrote each of these inequalities in different colors so that it'd be easier to see on the grid. So my y-intercept on the red one is -1. And my slope is 2 over 1. So from -1 I go up 2 over 1, up 2 over 1, and I keep repeating this pattern a couple of times just until I can kind of see my line. Remember, the inequality symbol tells you two different things: how to do the boundary line and where to shade. So my boundary line, because this is greater than, is a dotted line. So connect all of your points with a dotted line. Now I'm going to switch to the blue. The y-intercept on the blue one is +3. And the slope on this one is -4 over 1. So from +3, I go down 4 and over 1. Down 4 over 1. Because this is a less than or equal to sign, it's going to be a solid line. Anytime you see the equal to underneath it, it's an automatic solid line. So I'm going to connect these points with a solid line. Sorry, it's not straight. Now we have to shade. We shade only where the two areas overlap at. Okay? My red line says I need to shade above because it's greater than. That only leaves me two areas right up in here. My blue line is less than or equal to, which means I have to shade underneath the blue line. So out of the two areas, which one is under the blue? That will be this area right here. So this is where you shade. This is the solution region that satisfies both inequalities. Here's another system of linear inequalities to graph. Y is less than or equal to 2x minus 5, and y is greater than 1/3 x. Again, start off by determining your y-intercept and your slope for the red one. The y-intercept for the red is -5. And my slope is 2, so I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Again, repeat as much as you need to so that you can get an idea of where the line is. Because it's less than or equal to, do we do solid or dotted? Remember, anytime you see the equal to sign, that's a hint to remember that it's a solid line. Okay. Next, we're going to switch to our blue. What's the y-intercept on the blue one? And don't say nothing, because the number for nothing is 0. Slope for this one, for the blue, is 1/3, so that's up 1 over 3. Up 1 over 3. Up 1 over 3. What kind of line? Solid or dotted? Should be dotted. Sorry that it's not straight. And now we have to find the shaded region. Again, this is the area where they overlap for both inequalities. Because they're a system, they work together. So according to the system, the red one is less than or equal to, so that means I have to shade below the red line. This is above, this is below. Okay, so that means I can only shade below the red line is only right here in this side of the screen. I have to shade above the blue line because it says it's greater than. And there's only one place where it's above the blue line, which is right here, and at the same time it's below the red. So this is where I'm going to shade. Let's examine the solution region for the last problem that we just did. The solution region is the area where both inequalities overlap on their shading areas. Okay, and that's the orange area. That means any point within this orange shaded area in between these border lines is a solution to both systems of inequalities. Let's test it out. I'm going to choose a point right here. This point is 6, 4. And what I'm going to do is I plug in 6, 4, an x and a y, into the inequalities. And you see if both of them check out to be true. So here's the solution point that I chose from the shaded orange region. And I'm going to plug in this point into each of the inequalities. So this is my x and this is my y. 2 times 6 is 12. And 12 minus 5 is 7. On the other side, I have 4. 1/3 of 6. Remember, it's 6 times 1 is 6, and 6 divided by 3 is 2. And I forgot my equal to sign on this one. Okay. So let's go through it. Is 4 less than or equal to 7? Yes, it is. Is 4 greater than 2? Because both of these check out, that's how you know this is a solution point to the system. I picked another point that was outside of the orange solution region. 0, 0. 0, 0 is actually a point that was on this inequality line. So let's see how it goes. Okay, 1/3 times 0 is still 0. And over here, 2 times 0 is 0. Okay, let's check out and see what we have. Since 0, 0 was on this line, can 0 be greater than itself? well, no, it can't be greater than itself. It can only be equal to itself. And then over here is 0 less than or equal to negative 5. No, it's not. It's actually greater than. So because of this, this point does not fit the system. So he's not a solution point.